The purpose of the project is to study the circulation and mixing and stirring in the Gulf of Mexico. And the way we're going to do that, is to put tracer in at 1,100 meters depth around the northern edge of the Gulf of Mexico and follow it for a year as it mixes and stirs around in the ocean. And at the same time, numerical models will be run, and we'll compare the results from the tracer with the models to see how the models are doing with the circulation. So that's in a nutshell what we're trying to do with the overall view. In the back deck there we have a tracer injection sled. It has, the tracer itself is a liquid down at pressure, but it's not very soluble, and so we have to atomize it into tiny droplets, and that means that we have to pump it through small orifices to create small droplets. So that takes a pretty big pump and quite a bit of energy. So there's two big batteries on the sled and two big pumps and a set of orifices that are just 1/1000th of an inch diameter. And there is also on there a reservoir of tracer, which will holds about 40 kilograms of tracer, and an instrument to measure the temperature, salinity, and pressure of the water, so we know exactly where we are in the hydrography, and we try to keep the sled at a constant density of the water as we tow it along. Okay, these are tracking floats. They're called Rayfos floats, and they will be put in. There are 6 of them. You can see 3 here. They will be put in with the tracer, and they will come up at various times when we're trying to find the tracer. So they'll go in at the same depth as the tracer. They'll be timed to come to the surface and relay their position by satellite after various amounts of times. 2 of them are going to come up on a fairly short time so that we can go back right after the release to see how the tracer is distributed after the release. And the other 4 come up, 2 at 6 months or maybe 5 months after the release, and the other about a year after the release, which is when we have sampling surveys planned.
Okay.
We come back out here in December and again in June with our sampling, and these are just to guide us, so we want to see a detailed distribution of the tracer. Yeah, and plus, who knows whether they go the same way the tracer does. These are little surface drifters that were sent to us by our colleague in China, and we are putting those in for him. They don't have too much to do with the deep circulation because they're going to flow along the surface, but they will give information again for the models about the surface flow. Yep.
This sled is not quite as sophisticated. The CTD is running so that we can measure temperature, pressure, and salinity, calculate density, because the tracer was injected along a specific density layer in the water. So we want to maintain the sled height right along where we injected the tracer earlier in the trip. We have a couple of different types of sampling systems. There is a Medusa, we call it, due to all the tubes on it. It looks like a character Medusa. And each one of those is connected to a syringe. As we tow the sled through the water, it'll draw a single sample, I believe it's every 10 minutes. And then there's 50 syringes. So that gives us a snapshot of the water at that spot in time along the tow. The other samplers are integrating samplers, and they draw a sample in over the entire length of the tow. So they're averaging. And in the early stages of the injection, it's very streaky. It's long, skinny lines of tracer because it hasn't had a chance to really mix. So the integrating samplers will tell us that along our path we did indeed cross some tracer. Where the syringes, as we sample each one, most of them will be empty, but the ones we hit will know that at that point in time there was a streak of tracer, and that gives them a better three-dimensional map of what it looks like. We also place integrating samples above and below the sled so that we get an idea of how thick the tracer streak has become over time. Grading samplers are spaced out 4 meters apart. There's 10 above and 10 below the sled. And then there are 2 on the sled itself. They're simply clamped onto the wire, very old school, no high technology there. And the sampler draws its sample by a spring-loaded piston that over time it contracts. That draws water into a cylinder. On the inside the cylinder there's a mylar bag which is open to seawater. So as the piston slowly moves, it's slowly sucking seawater into that bag over the length of the tub.